Good afternoon, Algebra 1B students. Today we're continuing our work with systems of equations, and you're expected to solve them using the elimination method. However, like I was talking about the other day, I'm perfectly okay with you using substitution or graphing method if you find that to be simpler. Today's focus, though, is on word problems. The first word problem says Andy's buying 20 tickets to a school play. Adult tickets cost $4 and children's tickets cost $1 each. If Andy spent $32 total on tickets, how many of each did he purchase? The first thing that we talked about was making sure that we set up what x equals and what y equals are two variables needed for the systems of equations. So I'm going to say x is adult tickets, y equals children's tickets. Of course, those can be switched around. The first equation is typically always a total. So the number of adult tickets plus the number of children's tickets was 20 total. 20 of them were purchased. Then the second one is where you go in and assign the monetary value to it. So $4 for every adult plus $1 for every children equals $32 spent on tickets altogether. Now, like we talked about on Tuesday, when I go to solve, well, I guess it was Wednesday, the only day we've had school so far this week. When we go to solve this, we can use the elimination method because both of our y values are the same. Since they're the same, if we subtract, they'll eliminate. So we'll subtract the entire two equations. X minus 4x is negative 3x, 20 minus 32 is negative 12. Divide each side by negative 3, x is 4. So 4 adult tickets were sold. Then plug that back in. We know that there was 20 tickets sold altogether, minus the 4 adult tickets leaves us 16 children's tickets. Don't forget to label your answer. You can always check your solution by plugging it into both equations and making sure that it works. Second one is a little bit more challenging, but you got this. This is a classic, kind of like you might hear an airplane flying against the wind and an airplane flying with the wind. Only this one is talking about the speed of a barge in still water and the speed of a barge against the current. So I'm going to let you go ahead and read the problem as it is, but you'll notice that the barge can go faster downstream when it's traveling with the current than when it's traveling against the current. So I'm going to say that x is the speed of the barge in still water and y is the speed of the current because we need to figure out both of them. The great thing about this problem is they kind of give you this model to use right here, and all you basically have to do is plug in your x and y variables and your equation with your numbers and the speed, etc. But we'll go ahead and walk through it. When you take the speed of the barge in still water working against the speed of the current, y, so you subtract the two, it's going to travel slower at 3.8 miles per hour. But when you take the speed of the barge and the speed of the current and they're working together, it's obviously going to go faster, which is 8 miles per hour. Again, this system is set up perfectly for elimination. I would suggest adding, so if you do that, the negative y and the positive y are going to cancel each other out. It's allowing us to solve for x. 1x plus another x is 2x equals 3.8 plus 8 is 11.8. Divide each side by 2 and x equals 5.9. That means that the speed of the barge in still water is 5.9 miles per hour. Now remember, when they work together it goes 8 miles per hour. So you can subtract the 5.9 from 8 or plug it back in for x and solve for y, either way, and y is 2.1. After I subtract 5.9 from 8, the answer is 2.1. So the speed of the current is 2.1 miles per hour. Now again, the barge of course moves faster when it's traveling with the current than against, so that makes sense that the speed of the barge is 5.9 and the speed of the current is 2.1. Always go back in and check your two values into both equations to see if they work out okay. Now that we've completed the word problem practice, your job is to go ahead and do the homework practice problems. I'd like for you to do all the evens and the two word problems at the bottom. Please be respectful for the sub. You may work together, but the expectation is that both of you have the necessary work on your paper. Have a good afternoon and a great weekend. We'll hopefully see you on Monday.